Have a look at this cute little circuit that sits on my bathroom wall. Now, what it does is that suppose one comes in at night and one doesn't want to switch on the bathroom light, but one wants just a little LED to glow so that you can see what you're doing in the bathroom at night. Then here's a little switch, you press it, and you see there's an LED that comes on. Now it stays on for about 2 to 3 minutes and then it snaps right back off. So one would have to wait 2 to 3 minutes and you'll see that it snaps off instantly, but it glows at the same brightness for the 2 or 3 minutes. So this is really just a little timer circuit. It's got some sort of MOSFET chip there. That capacitor plays a role, that resistor plays a role. There's another resistor that's for this LED. And then it's got those 4 batteries. Now this thing, those batteries will last for years. Literally, I've had this circuit for about 10 years and I've only changed the batteries once. So this was a little circuit that was designed so that at night you could come in, you don't have to turn on the main light, don't have to disturb everyone. And also you're sleepy at night, so you don't want to switch a bright light on, which will then make you completely awake. Now, also something that is very nice about this is you could have a little switch, and I used to have just a little switch here, but the thing was at night, half asleep, I would forget and I'd leave the light on and come back and then finally find that the batteries have gone flat. So that's what motivated me to try and find a circuit that will automatically switch itself off, as this does. And you'll see that that little light just snaps off in a moment. So we'll find that it'll stay on for an exact amount of time, which is determined by the size of that capacitor and probably that resistance here. I forget the circuit because it was made many years ago, but I think this is a decimal counter, a MOSFET decimal counter of some sort. And the beauty about MOSFET things is they use almost no current. That's why the same batteries can work for years. And then they're also very snap on, snap off, unlike the normal transistor circuits. Now, MOSFETs are a little bit more expensive, but it's so worth it for the snappiness of the way it snaps on, snaps off, and the fact that they don't waste current at all. So we'll leave that on just to see how long it actually takes before it snaps completely off. Now, it was this idea came from a circuit there. You saw it just went off there. Did you see how immediately it snapped off? This idea came from I'll show you a circuit in a moment, which was my basic circuit. And then I went on to Electronics Point, which is an electronics forum, and asked them, could you design me a circuit that does exactly what this does? And it does it to perfection. But I'll show you what my original circuit looked like. So here was one of my original attempts, a circuit somewhat like this, to create a circuit that switches on and has an LED just glow for a short period of time. You see this big boy here? That's a capacitor. And this is a 2200 microfarad capacitor. Capacitance is measured in farads, I guess named after Faraday, one of the recent inventors. So there's the symbol for a capacitor. It's like, this is a capacitor that must be attached in a certain way. You must attach the positive lead to the positive electrode and the black to the negative electrode. So it's got a lighter positive plate. It's actually just 2 plates together. It's like a little mini battery. And when we attach the real battery, it charges this up, and then we can take the battery away. So let's just put in the positive lead. And let's put in the negative lead and just see what happens. You see, now I can take the battery away And this has been charged up, and you see how that LED glows. And you can see the LED glowing. It's got a resistor there that protects the LED from being burnt out, but what you'll see is the LED slowly gets dimmer and dimmer. I'm just going to point this LED more towards the camera, and let's recharge that once more. So we put in the positive. We just have to charge up this capacitor by just touching it, and you see that LED glow. Now we can take the battery away, and it will slowly get dimmer and dimmer. So what's happening is this capacitor is slowly discharging, and as it does, it just charges through the LED, and the LED lights up. But when this is run out of its charge, the charge is stored on those two plates, then that just goes completely dim. But you can still see there's a little bit of light still. Okay, so that was one idea. Then I came with this idea. And here we have a battery that is connected permanently. So let's take this battery and we connect it. There's the positive and there's the negative. Here's the LED. You'll see that it's not on. But we have a transistor. Normally, if we touch that and that, we can charge up the transistor's base and get it positive. But because this is such a big boy, it's going to take such a long time to charge up, I can actually take a piece of wire and just charge it like that. Now this has been charged up, and it is biasing the base over here positive. Again, this has got a positive side. There you see on the diagram the lighter positive side, and it's got a negative side. Watch, the negative side goes through the 30 ohm resistor to the negative terminal of the battery. So this is all 0 volts, 0 volts, 0 volts, 0 volts. And then this gets charged up. Now you can still see that this is glowing. What this capacitor is doing is it's keeping the base positive. And as long as the base stays positive, which means while this is discharging, our LED will glow. But again, do you see that it's getting slowly dimmer and dimmer as the base is, as this capacitor is discharging. And what is it discharging? It's discharging, there's a current that flows into our transistor. So we have a main current come here from the positive through a 470 ohm resistor, through this LED. Notice the symbol always points in the direction of conventional current. Then it flows through this NPN transistor. Here's the collector, here's the emitter, here's the base. The current flows through the collector. If the base is biased positive, which it is by that capacitor, the current flows through it, so it acts like an open switch. This is an open switch. And then the current flows back to our negative terminal. But as this capacitor discharges, you find the base becomes less and less positive. And this becomes more and more like a closed switch. And as it becomes more and more like a closed switch, this gets duller and duller. It's glowing more and more dimly. And so you can see that although it's glowing dimly. So as this discharges, our LED glows dimmer. Now that's not so great. If you're going to a bathroom, you want to be fully on, fully off for a set amount of time. So we could use a proper timer chip, like a 555 timer, any 555 chip, and those are specifically designed to switch on and off for a period of time. But those 555 chips use a lot of current, so you're going to find that your batteries will flatten very quickly. And that is why I prefer the circuit that I showed you. So there's our battery pack. And you can see that if the whole aim of this game is to have it switch on just for the 3 minutes, and when it's off, you don't want the circuit to be drawing current. Now, I'll just charge it up by shorting between there's the collector and the base. The current goes through here, through here, through. The positive current charges this side of the capacitor positively, and now you'll see it's all bright again. Watch, I'll charge it. It's all bright again, and slowly it'll get more and more dim as this loses its positive charge to the base. So some current is flowing through here and some is flowing through here, and both come together in the emitter and then they flow back. There's our closed circuit. This capacitor, we don't really need that resistance, but I just put a resistor, very tiny resistance, 30 ohms there. We just basically need a capacitor, and the negative side has to be connected to the negative side of the battery. So all of this is what is keeping the base positive and is biasing the base positive, especially when I touch a wire between the collector and the base. And that wire allows a current to charge the base positively. Normally we can just put a finger, but because of this big boy, it takes so long to charge it up. A finger doesn't allow enough current to charge this 2200 microfarad capacitor up. So this circuit is not ideal. Although when it does go off, it doesn't use any current because this is now completely switched off. But I don't like the way the circuit used to just slowly, even before you finished with the bathroom, would be getting dimmer and dimmer. So it's helpful to know a little bit about electricity and circuits. Join a forum, whatever, electronics forum. And they were the ones who helped me design that other circuit, which has been working so fantastically for about the last 10 years.